My name is Seito Emori. I'm working for a National Institute for Environmental Studies on the climate modeling for 15 years or so. I started my training as a climate modeler. It is like a computer game, you know. That's one reason. But another reason is that I have been interested in the relationship between science and society, and climate change is a very good question for me to tackle when I choose that subject when I was in university. In my lecture about climate projections and uncertainty, I'm going to explain what is the climate projections from the standpoint of climate modeler, and what's uncertainty. There are three major sources of uncertainty. One is scenario uncertainty, which is important for long-term future projections. And the second is natural variability. This is a random fluctuation of the climate year to year or day to day. And that is important only for short term. And finally, I will spend most of my time in my lecture about so-called model imperfection. There is an important part of uncertainty because of the imperfection of the model. And I'd like to explain that from my experience as a climate modeler. The second lecture of mine is titled Selecting Appropriate Future Climate Projections for Impact Assessment. And that is a very challenging issue. And there are several or 20 or so different climate models. And they are slightly different to each other in terms of the current climate simulation and the future climate simulation. And you can pick up one or two based on your evaluation of the model's current climate simulation. Because there's only, for the current climate, you have observation. You don't have observation for the future climate. You have to evaluate your model for the current climate. But that doesn't guarantee that model's credibility in the future projection. That's the problem. And I don't have a clear conclusion on that problem, but I try to explain the evolving science to deal with that complex problem.